Hypothalamus, artificial intelligence. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents its solutions for Homeland and Cybersecurity advanced analytics. Disaster and emergency management implies. The challenge: develop a DSS for disaster and emergency management. The overall objective is to minimize potential negative economic impact and human life losses. The solution: design a set of mathematical models to address the problems arising from disaster management based on stochastic programming models. The benefit: a set of measures and mathematical models to prevent and/or reduce the impact of disasters, and it prepares the community to respond in the best way when a disaster strikes. Actions before mitigation: set of measures to prevent or reduce the impact of disasters. Preparedness: preparing the community to best respond when disaster strikes. Actions after reaction: the use of resources and emergency procedures to preserve the life, property and environment of the community, since the disaster is occurring. Recovery: set of long-term actions to stabilize the community and return to normalcy. The mitigation and preparation of disasters caused by nature implies. The overall objective is to minimize the potential economic and human loss, and continuity of operation of the economic system. To this end, the historical behavior of nature is studied, trying to know probabilistically what can happen in order to make decisions of where, when and how to allocate resources to mitigate and/or prepare for the disaster. For disasters caused by the humans, it implies. The overall objective is to minimize the potential economic and human loss, and the social impact of the terrorist attack. To do this, models are proposed that study the opponent and hypothesize the decisions that can be made, using game theory models, on where, when and how to allocate defense resources. The reaction and recovery after the disaster occurs implies. Actions during the disaster, and reconstruction actions. The general approach of HI is to connect predictive and prescriptive analytics models, which implies an integrated holistic vision, multidimensional space-time, of the entire supply chain of disaster response services. Predictive analytics is based, mainly, in artificial intelligence, machine learning, and complex probabilistic methods. Prescriptive analytics in mathematical programming, better known as optimization. Human conflict planning. Sun Tzu, in the book The Art of War said, "Every battle is won before it is fought." In the war on terror, planning supported by the scientific method can avoid conflicts, so that many battles are won without a fight. Activities to ensure safety. These mission areas may be grouped based on when a defensive action is intended to occur, either before, during, or after an attack. Proactive planning. Mission areas whose defensive actions are taken before an attack occurs. These mission areas are prevention/protection, and mitigation. Real-time operational planning. Mission areas whose required actions are taken during or immediately after an attack. These mission areas are detection and response. Recovery planning. Mission areas whose required actions occur after an attack. This mission area is recovery. The state-of-the-art of scientific planning of confrontations, attackers versus defenders, is the use of competitive game concepts developed by John Nash. Security games study the convergence property to the equilibrium of a sequence two-player dynamic games, played by an attacker and a defender. The fundamental features of the game are: the evolution of the game is based on a stochastic fictitious play process. Players do not have access to each other's payoff matrix, and each must observe the other's actions up to present, and plays the action based on the best response to these observations. When the game is played over a communication network, there are another practical issues that need to be considered. Network latency. The players may make random decision errors from time to time. The players' observations of each other's previous actions may be incorrect, and the players will try to compensate for these errors based on the information they have. Homeland Security Optimization. It is a concerted effort to prevent terrorist attacks within a country or a region, to reduce vulnerability to terrorism and crime, and minimize the damage and recover from attacks that do occur. The main Homeland Security applications based on Operation Research are Allocation problems. Police patrolling for subway and bus systems, other scarce resources including bomb-sniffing canines, vehicles, and security cameras, randomized baggage or people screening, allocates air marshals to flights originating in and departing from the country, allocates patrols at ports to minimize the risk of terrorism and drug trafficking, protecting forests from extractors, and cameras allocation to reduce security cost at metro and public transport. Scheduling problems. Scheduling for the Federal Air Marshal Service on commercial flights, and scheduling for police patrols and other police vehicles. And others problems. Evacuations plans, passenger classifications, and vehicle routing of dangerous materials, or people, that minimize the danger of humanity. Cybersecurity optimization. Cybersecurity is the collection of tools, policies, security concepts, security safeguards, guidelines, risk management approaches, actions, training, best practices, assurance and technologies that can be used to protect the cyber environment and organization and users' assets. It aims to reduce the risk of cyber attacks and protect against the unauthorized exploitation of systems, networks, and technologies. The number and variety of cyber attacks have significantly increased. It is becoming increasingly challenging to protect against these attacks. We need to find solutions to provide a holistic protection against a wide range of cyber attacks on a variety of target systems. Artificial intelligence, machine learning, and mathematical programming have flexible and adaptable behavior, and can help overcome these challenges by providing a holistic protection against cyber attacks. Cyber intelligence is the collection of data and information related to the security of an organization, business, or state, to process this information, to develop and implement strategies to protect their operation, assets, and interests. Some examples of cybersecurity applications based on operation research are: planning problems. To select optimal portfolio of security safeguards, to minimize cybersecurity investment and expected cost of losses from security breaches in a supply chain, and to select a subset of security controls, among many available ones, is a resource allocation problem that should consider conflicting objectives. The security should be improved, without hindering productivity, under a limited financial budget. Scheduling problems. Applying machine learning to make the process of malware detection more actionable, scalable, and effective than traditional approaches, which require human intervention. Define a set of network security defense strategies, with the goal of reducing the probability of a successful large-scale attack, in a dynamically changing and complex network architecture, and to detect and correct cyber attacks in the measurement system. It implies, to examine the detection, classification, clustering, and analysis of anomalies in the network traffic. Real-time decisions. Network security defenses must evolve, responding to real-time attack incidents, modifying the underlying topology, or reallocating defense systems across the network. Game theory applications. To provide the best strategy for the defender, by reducing rogue packets that seek to flood the bandwidth of the network, in a distributed denial of service attack, DDoS, that occurs when the attackers flood the link, in such a way that legitimate users are denied access to a target resource on the network. The evolution of the game is based on a stochastic fictitious play process. Players do not have access to each other's payoff matrix. Each must observe the other's actions up to present, and plays the action generated based on the best response to these observations. However, when the game is played over a communication network, there are several practical issues that need to be considered. The players may make random decision errors from time to time. The players' observations of each other's previous actions may be incorrect, and the players will try to compensate for these errors based on the information they have. Hypothalamus artificial intelligence. The creator of the artificial hypothalamus technologies. Thank you for your attention.